you're joining us online, I apologize. I just have video here. I'm just going to put that on the screen for a second. Okay, so going to our inequality, talking about our inequality there. So we have this equation, it worked there. When we try to put it as an inequality, I'm hoping you'll notice that you go to put this in. So I give 3 times 2 plus a negative 1. We're saying, is that less than 5? So we get 6 minus 1, is that less than 5? Is 5 less than 5? Kind of a weird question. Is 5 less than 5? No, they're equal to. So what we're going to learn today is that, so like again, like if I say you have to be under 5 in order to like ride this ride, like a little kiddie like ride at like, or been like Bay Beach or something, you need to be a certain, hi.
Mr. Dexter.
Oh, sweet, thank you. Yes, that's fine. So, sorry. So 5 is not less than 5 because they're equal to. Now, if it had the equal to line, it would be okay. But since it doesn't, we just say no, that doesn't work because that's our cutoff. And so this is a no, and we're going to use that today in what we're talking about. And we're going to talk about what the solutions would be for this inequality. So the way we're going to find these solutions is we're actually going to use the graph to do that. And we're actually going to be coloring part of the graph because half of the graph is going to work and the other half is not going to work. So we're going to see that here in our lesson. So we're going to graph linear inequalities. I'm going to write the steps down here as we're going, and then we'll actually do an example when we get to the back side there. Can you write down those other parts though, please? Guys, you got to be taking notes, please. This is somebody's water bottle before I kick it. Oh, at you. So to graph our linear inequalities, what we have to do first is we need our equation in y equals mx plus b. So we're going to do that first. So we're going to write the equation. So we need to solve for y. We're going to do that. Remember, b is where we begin. And m is how we move. Now, when we solve for y, I'm going to let you guys know that today, rather than having the equal sign, we're solving inequalities. And if you guys recall, there was an extra step of solving inequalities that was really, really important. That when we are solving inequalities, if we multiply or divide by a negative, we have to flip that inequality. That still happens when we graph. So as we're solving, I'm going to write if we multiply or divide by negative, we're going to flip the inequality. So that's on that solve step. So that might happen in that first step of the problem. So we're going to graph that line. But before we draw the line, we're going to draw the dots. And then before we draw the line, it's going to be really important for you guys to know we're going to draw a different type of line depending on the inequality. So in our inequality, greater than or less than has a different type of line than less than or equal to or greater than or equal to. So our line type, we're going to have a dotted line if it's one of these two. So if it's greater than or less than, we're going to have a dotted line. So that means the line is not going to be like a solid line as part of our solution. So in this one, we're going to say the line is out of bounds. So the line does not work. So there's different games you play, and the line is out of bounds and the line is in bounds. I think volleyball is the line in bounds if it bounces on the line. But in football, if your foot's on the line, you're out of bounds. So it depends on the problem, and it depends on the game that you play. That's the same idea here. There also can be a solid line, and that's when we have that equal to line. So that line's going to be solid because that line is going to be part of the solution. They kind of look like little faces. If that helps you remember, I don't know, but somehow we got to memorize the difference. So we're going to graph this line, and rather than automatically just connecting the dots, sometimes we're going to do this little like dash or dotted line in those situations versus just a regular solid line. Now the last step of this is we're actually going to color half the graph. So what we're going to find out is going back to these graphs. So we're going to picture these lines as like a dividing line. So this is like our boundary line. Either one side of the line is going to work or the other one's going to work. So it's kind of like a yes or a no. So like if I said, I'm going to grade your homework tonight or grade your test based on what side of the room you're on. And I'm going to pick one of you guys at random, and we're going to use your grade. So like let's say I look at the question and Danica got it right, so her whole side of the room got it right. But if Danica got it wrong, then the other side of the room is going to get like that point. So she's like the test person for the whole side. Or I have to pick one of the people on that side of the room, and you guys are all together. It's like a team. So that's kind of what we're going to do here is we're going to say, we're going to test a point on one side of the line. If it works, then all of them are going to work. If it doesn't work, then we assume the other side is where our solutions are. So the way we're going to show that is we're going to shade that side of the graph. So you get to color. We're back in like kindergarten where we get to color on our homework. Bring out your colored pencils. So we're going to test a point on one side of the graph. We're going to test a point on one side of the graph. If that point works, we're going to shade that side of the graph. So we're going to shade that side. So it's kind of like lightly shade that side. So if the point works, we're going to shade that side of the graph. If the point doesn't work, we're going to shade the other. And then what if it doesn't work? You need to write, please remember everything I write down. Okay, so we're going to do an example of this, then we'll take a break. We can just do one and then so we're going to do example one on the back side. So on this backside, this equation's already in slope-intercept form, which is really, really nice. That That takes a lot of the work out of this. We'll deal with it when it's not that way after our break. So we're going to start by graphing this. So this is already in y equals mx plus b. Now notice it's not an equal sign. It's that less than symbol. Right away when I see that less than symbol, I want to like kind of put like a little note down so I know what type of line this is going to be. What type of line will we have? This is going to be a dotted line. So if you want to somehow up here write something that'll help you remember that so you don't forget that, somehow that you know that line should be dotted. And it's because it's that type of inequality versus having the equal to line. Okay? Where does this graph begin? It's going to begin at -6. So our b is -6. That's our beginning point on our y-axis. So I'm going to put a dot at -6. Then my slope, my m is, what's m? 2. So I'm going to put this 2 over 1. So I'm going to go up 2 and over 1. Now don't go too fast for me and then draw a solid line. Remember, this should be a dotted line because of the fact that that solution is not part of the, like this is the volleyball rules where if it hits the line, or no, if it hits the line it's in. This is the opposite of that. It's the football rules. Careful, up 2 over 1, you're going up 2 over 2. Up 2 over 1. So we're going to do our dotted line. And in this case, I would highly suggest going a little bit further than you typically would. You don't want just like 2 little dots and try to draw the line. And a dotted line is kind of a goofy one. You might be like, well, that's not very, it doesn't even look like anything's happening there. So somehow you want to make sure that your line looks kind of dotted. Even if you just put arrows on the end, I'm really okay with that, especially when they're like this close together. But we're not done. This is where we get to do our coloring. Get excited about that, you know. We get to do coloring. So what I mean by that is we have to check, is all of this a solution or is all of this? So this is where we're going to test just one spot, and that spot's going to give us the solution. It's going to tell us if it works or not. Does anyone have an idea of a really good, easy spot to test? What would be a point that I could pick on this graph that would really help me to check a good spot? Yep. 9-3. I would not probably choose 9-3. It would work, but
3-0.
there's probably an even. You're really close.
1-0. 0-1. 0-0.
How about 0-0? I really like testing 0-0. I like picking points that they're the same. X and Y are 0 because I can't get them mixed up. They're both 0. And they're really easy points to put into my equation. Now, I have to pick a point. Now, this is important. I probably should have wrote this on the other side. You have to pick a point that's not on your line. So I'm going to test 0-0. And 0-0 is right here. I'm going to check that. So that's like when I said I was going to use Danica as an example, that I'm going to use just her test question, and you guys all get that grade on this side of the room. She got it right. You guys get an A. The other side gets an F. Like, obviously, that's not the way we grade, but that's the way we're testing this. So we're testing 0-0. We're going to put those points into this equation and see if it works. So y is 0 is less than 2 times 0 minus 6. Get that think a little bit. 0, this would be 0 minus 6. What's 0 minus 6? -6. So is 0 less than -6? No. Think about the coldness of the day. 0 is actually warmer. That's like when we finally were feeling like it was okay to be outside. Maybe not really. But 0 is warmer than -6. So this is wrong. This does not work. So this one got it wrong. That means everyone else around it also got it wrong. If I tested any of the points on that side of the line, it wouldn't work. So what we have to do now is this yellow line is the divider line, or the orange line. I'm going to color on the other side. So I'm coloring over here. So the colored spot is where my solutions would be. So that whole side of the graph would work. So you need to color your graphs. If you guys turn in your homework tonight and it does not have graphs colored, you're not getting full credit for that. Just like today, if you turn in your homework and you only had one solution for all of these, you're missing that other answer. If you forgot to graph, like those things are important details here. Okay? Now we're gonna finish up like right before break here with these last two parts of this. So it says, is 3, 0 a solution for the, is 3, 0 a solution for the inequality? So does this work in the equation? 3 zeros on our line. Do you guys remember what we said about this type of line?
It don't work.
This one doesn't work. When it's on this line, since it's a dotted line, we'd say it does not work. So it's no, it's on a dotted line. All right. My next question, is 10, negative 14 a solution? Well, gosh, that's like off my graph. It's down over here. But would that be part of my solution if I was shading? Like really, yeah, technically I should be shading like this whole side of the page. Don't shade the whole side of the page. But I should keep coloring because the graph doesn't just stop there, but it's on the side that's good. So we'd say yes, it's in the shaded part. Okay? So we can take a little break here. Oops, I should make sure they got that. My other classes, since it's Friday, we did a fun Kahoot. I don't know if you guys want, what you guys want. Is it